And that was the case today concerning Mount Rainier. Here in Washington, we have our own volcano threat in the Cascade Mountains. Towering over the evergreen forests and vibrant cities of the Pacific Northwest, Mount Rainier is both a beacon of wild beauty and a silent sentinel on the skyline. Ascending 14,411 feet above sea level, its icy peak is visible for miles, a striking reminder of the turbulent forces that shape the Cascade Range over millions of years. Each year, thousands of adventurers are drawn to its snowy slopes, and millions more gaze up in awe, perhaps never fully aware of the vast energies contained beneath the mountain's tranquil surface. Yet, in recent days, a new murmur has made its way through this ancient landscape. A swarm of hundreds of small earthquakes has rippled beneath Mount Rainier, the largest seismic swarm at the volcano since 2009. Agencies like the U.S. Geological Survey, the Cascades Volcano Observatory, CVO, and the Pacific Northwest Seismic Network, PNSN, are carefully monitoring every subtle movement, every shifting fracture beneath the Earth's crust. Despite this uptick in earthquake activity, the USGS maintains that Mount Rainier's alert level remains at normal. There are no signs of an imminent eruption. Still, scientists acknowledge that the current earthquake activity is unusually high for this well-monitored volcano. What does it all mean? Could Mount Rainier, under the right circumstances, unleash its pent-up force once more? An even more intriguing and perhaps unsettling question lingers. Could an eruption at Rainier trigger a chain reaction across the Cascade Range? How real is the threat that one of America's most iconic volcanoes could set the entire spine of the Northwest trembling? Join us as we untangle the mystery at the heart of the Cascades and explore the dynamic forces that bind these ancient volcanoes together. Are the mountains truly sleeping or simply waiting to awaken? The Cascades, a range forged in fire stretching for over 700 miles, the Cascade Range is far more than a dramatic sweep of peaks and glaciers. It is a dynamic chain where geology, history, and destiny are woven together by forces as old as the planet itself. From Northern California's Lassen Peak through Oregon's legendary Mount Hood and Crater Lake to Washington's formidable Rainier and the infamous St. Helens, the Cascades stand as testaments to both creation and destruction. This landscape was forged in fire. For millions of years, the slow but relentless grinding and subduction of tectonic plates have produced lines of volcanoes along the Pacific Northwest. As the oceanic Juan de Fuca plate dives beneath the North American continent, molten rock rises through the crust, sometimes erupting explosively, other times building quiet, massive domes. This is a region defined by its volatility, a land in which entire ecosystems have been swept away in fiery eruptions only to regrow in unexpected forms. Mount Rainier, with its gleaming cloak of snow and ice, seems at first glance a world apart. Yet it is intimately connected to its siblings throughout the range. Like Mount St. Helens, which erupted spectacularly in 1980, or Mount Hood stirring with its own geothermal activities, Rainier's story is part of a larger saga. Each volcano holds its secrets and tells its own tale in ash and stone. Some have ancient calderas, others fresh scars, and all are alive with a hidden pulse detectable only by sensitive instruments stretching across the Northwest. When seen from above, the volcanoes of the Cascades form a near-linear chain, a series of sentinels shaped by the same relentless processes. But do they share more than just a common origin? Could these giants, connected by the circumstances of their birth, influence each other in times of unrest? The mere thought is at once mesmerizing and unsettling. Is the awakening of one Cascades volcano destined to quicken the rest? Mount Rainier's recent earthquake swarm signs and signals. In July 2025, the very foundations of Mount Rainier shuddered in a display of subterranean unrest that drew the eyes of the geological community. Hundreds of microearthquakes, far more in number than usual, rattled the rock under the mountain in what scientists call a swarm. For the USGS and its monitoring partners, it was the largest such swarm recorded at Rainier since 2009. But what exactly does all this seismic activity mean? Are these earthquakes warning shots or simply the mountain's way of tossing and turning in its geological sleep? In reality, earthquake swarms are not particularly rare at Rainier. They may occur once or even twice a year. Most of these swarms, however, are smaller in both number and intensity. Experts say these events most often reflect shifts related to underground water, steam, or gas movement through cracks in the volcano, or occasional readjustments along faults under the mountain. Sometimes swarms can be connected to the movement of magma, but more often they are the result of the regular churning beneath an active stratovolcano. Yet the size of this latest swarm marked it as notable. Instruments deployed by the Pacific Northwest Seismic Network, PNSN, mapped each tremor in real time, allowing rapid updates and responses. Special GPS equipment scanned the surface for signs of swelling or shifting. Gas sensors monitored for changes in volcanic emissions, and satellites peered down to detect any ground deformations invisible from the ground. So far, the results have been reassuring. There are no unusual gas emissions, no visible changes to Rainiers, snow-clad slopes, nor evidence of magma pushing closer to the surface. U.S. volcanologists stress there is no evidence that Rainier is due for an eruption. The concept of a volcano following a set schedule is a myth. The reality is far more complex. Despite the volume of recent earthquakes, they conclude that the volcano's alert level remains at normal. There is no ash steam or new cracking on the mountain. Still, the public's curiosity is understandable. Could a persistent swarm like this be an early sign of deeper changes? History counsels caution, but not alarm. Although increased earthquake activity can sometimes precede eruptions, often it does not. Swarms may be resolved by shifts in underground fluids or by minor structural adjustments. The mountain quiets and the drama disappears except in databases and scientists' analyses. Yet in rare cases, an uptick in seismicity is the only warning before an eruption unfolds. For now, it appears we are witnessing a restless mountain, not an awakening giant. But such periods always provide the scientific community a valuable window into the inner workings of volcanoes, reminders that mountains which appear serene from above are often alive with change within.